Now we're gonna give a numerical explanation of a problem that involves Faraday's law. So the problem says, the magnetic field intensity is given by a certain region of space as h is equal to x plus 2y over z squared in the ay direction plus 2 over z in the az direction. And for this problem we have to find the current density at j, which is the first part. For the second part we have to evaluate j with certain values. So Faraday's law says a changing magnetic field in time produces a perpendicular electric field whose polarity opposed to the original field. And this means that nabla cross h is equal to j. So for this we use the curl, and well, we're given here a formula that is actually the curl, as you can see it on the screen. And now we're gonna substitute values from the given h. And well, using the curl we put all these values on this formula. So now that we have substituted the values on the equation, we look for these ones that make 0 because you don't have a component on the specified direction, or you cannot make the derivative on that component. So it looks like this. And now we know that the result is 2 times x plus 2y over z to the cube in the ay direction plus 1 over z in the az direction.
Now, here we are gonna explain the next step in this problem, the point B. It consists in finding the total current passing through the surface, C equal to 4, x in the range of 1 to 2, and finally y in the range of 3 to 5. The manner of doing this is using a double interval in the current density that we found before, multiplying this with the ds in the AC direction. In this case, dx is equal to dx and dy in AC direction. But why in AC direction? Because the problem specifies that we need to find the result in that direction. So, first, we have to substitute the formula with the values of current density and ds. As a pro tip, it's a good practice to put also the directions of each component in the equation before to solve it, because now we know which one we need to become it 0 and which one using the interval. As you see here, as I said, we know that we only need to use 1 over c, because it's the only component in the AC direction, because the other one values are 0. Now it's time to reduce the terms of the interval and specify which are the range of each integral, use the values of x and y, and if we remember, that values are x in the range of 1 to 2 and y in the range of 3 to 5. So now we can proceed to solve this equation. We can use Symbolab or Wolfram of any program in the computer to solve it, and finally get the result. The result is 2 over c squared. Now we can proceed to change the value of c, that is 4. So that gives us a fractional number as 2 over 16. And if we reduce at his minimum expression, we get 1 over 8, as you see here in the video.